plays an important role in our society. However, gold mines are facing various challenges: declining ore grades with complex mineralogy, compliance with environmental regulations, social license to operate, tailings management, and increasing chemical usage. Draslovka's Glycat is a revolutionary gold leaching technology that combines glycine with a very low concentration of sodium cyanide to selectively leach gold while providing substantial ESG benefits and cost savings. GLT reduces sodium cyanide consumption by 50% or more. It also reduces processing costs, minimizes WAD cyanide and detoxification costs, improves recovery from some ore types like tellurides, and significantly reduces the dissolution of mercury and arsenic. Unlock tomorrow's gold in a way that is safer and more cost-effective. Partner with the leaching innovation experts at Draslovka.
Well, welcome again, everybody. Thank you for joining us for the Unlocking Tomorrow's Gold webinar on Draslovka's Glycat leaching technology. My name is Jackson Briggs. I'm the Senior Product Manager for Glycine Leaching Technologies, or GLT for short. And I am joined today by Santiago Garcia, our Global Technology Leader, Rodrigo Tapia, our Senior Metallurgist for North America, and Dan Child, who is our Global Commercial Lead for GLT. So I'll start by giving an overview of the technology. I'll hand it over to Santiago and Rodrigo to go through a few case studies. Dan will go over how you can get started with testing the technology and what our engagement process looks like. Then we'll leave plenty of time for Q&A at the end. Please feel free to use the Q&A function in Teams throughout the presentation, and we'll make sure we answer as many as we can. It's in the Q&A tab up at the top. That'll pull up a sidebar where you can put in your questions, and our team will go through them and take that time at the end to answer those questions. So if you aren't familiar with Draslovka, we are the leading supplier of sodium cyanide to the gold mining industry. We have 700 people worldwide across 14 countries, with that list growing all the time. And we have a strong history of R&D in chemistry and a lot of knowledgeable metallurgists and chemists on staff, some of whom are here with us today. Over 95% of our customers say they would recommend us, and we have even more exciting products in the work beyond Glycat, including advanced real-time measurement devices and a tool for AI optimization of metallurgical processes that will help you get the most out of that data and the Glycat technology. But today we're here to talk Glycat. So Glycat is our patented technology, which uses glycine alongside sodium cyanide to generate a number of benefits, including lower cyanide consumption, reducing or eliminating the need for cyanide detoxification, and in some cases, increasing life of mine or improving gold recovery. So why glycine? What is glycine? So glycine is a basic amino acid that is used as a food additive for both humans and animals. So it's non-toxic and fully biodegradable. So it's much better for the environment than a lot of other reagents or lixiviants. But there are two things that make it fantastic as a leaching catalyst. First, it leaches metals selectively, so it will bond with some that you can see on the periodic table over there on the right, like gold, silver, and copper, but not with others like iron or arsenic or mercury that can be toxic or cause issues in the leaching process or downstream in smelting or in tailings. But there's two things that make it really fantastic as a leaching catalyst. So first, as I said, it selectively leaches certain metals, and second, it's not chemically consumed. So as a primary reagent, it's both recoverable and recyclable, which provides a major advantage in cost. So you can imagine, instead of consuming cyanide on a continuous basis, if you could recycle 50% of that or 80% of that, that'd be a significant improvement in your operating cost on an ongoing basis. So when you put this in practice in a leaching circuit, the results are pretty impressive. So first, you can see up to a 50% savings in processing costs, depending on how much of your processing OPEX is devoted to cyanide or reagents that address cyanide in the circuit. We can reduce cyanide by 50% or more. In a lot of cases, we've seen 70 or 80% reduction in cyanide consumption. And then by reducing the amount of cyanide, concentration of cyanide in the circuit, we can also reduce or eliminate the need for cyanide detoxification at the end of the circuit, because we're generating much lower amounts of both free and WAD cyanide. In some cases, we can increase gold recovery or silver recovery, depending on the ore type. So the video earlier mentioned tellurides. That's one where we've seen a significant improvement in recovery and leach kinetics. And then lastly, there's a significant reduction in dissolution of mercury and arsenic with Glycat when we reduce those cyanide concentrations. So the benefits from all these improvements can be quite substantial. From a cyanide cost reduction standpoint, we're looking at anywhere from 50 cents to $3 per metric ton of savings. From a cyanide detox cost standpoint, anywhere from 20 cents to $3 per metric ton of savings. And then, of course, there can be other benefits as well. You know, when you modify the leaching circuit, it's a complex system. So the pH, oxygen levels can be impacted positively by implementing Glycat. So some mines will see a reduction in cost for oxygen or lime or lead nitrate, depending on what their current operating state is. We've seen gold recovery improvement in some cases. And because we're reducing OPEX for deposits, we're also in discussion with a number of mines that are looking at extending their life of mine because they can take some of those marginal deposits that are higher cost, reduce the operating cost, and then process them profitably. There's a few operational benefits to Glycat as well. So first, it's easily adapted to existing leaching circuits without modification. We're really just adding another reagent to the system. So all you'll need is a new tank and a new pump. There's no novel process equipment, no major CapEx. It's just as simple as doing what you're already doing with cyanide and duplicating that in most cases. So in addition to the financial benefits, there's a number of environmental benefits as well from implementing Glycat. The first, obviously, reduction of cyanide and reduction of arsenic and mercury and tailings. So this International Cyanide Code standard for free and WAD cyanide in solution is at 50 ppm. A lot of operations operate at that. Some operate below 50 ppm in their discharge. So Glycat will lower the overall WAD cyanide that's generated either in your final leach tank. And so in a lot of cases, we can reduce or eliminate cyanide detox and just send that material straight out to tailings because it already clears those regulatory limits. Also, lower emissions of HCN gas formed during gold processing. So because cyanide concentration in the solution is lower, there's a lower threshold for pH modification and lower risk of HCN off-gassing if that pH drifts into an unsafe range. And then in addition to WAD and free cyanide, we also reduce or eliminate other cyanide species like SAD cyanide. And lastly, reduced environmental risk and carbon footprint. So we're in the early days of doing a study that shows pretty interesting results around the reduction of a mine's carbon footprint that's achieved by reducing the amount of sodium cyanide that's consumed. And there can be some pretty substantial benefits on that front as well. So now I'm going to pass it over to Rodrigo, and he and Santiago are going to take you through some technical case studies.
Thank you very much, Jackson, for the introduction. I'm quite excited about being here. Welcome to our webinar, and thank you for joining us. I'm Rodrigo Tapia, and I will be presenting part of our technical cases today. As you might note, Glycat transforms sustainable metal extraction by offering higher metallurgical performance, cost effectiveness, and ESG benefits. Our comparison table here outlines the typical conditions among the conventional cyanidation with Glycat. Above the red line, the conditions are similar for both. However, the differences below this line are material, showing Glycat as a game changer in the mining industry. For instance, Glycat requires significantly less cyanide, just 10 ppm compared to a 100 ppm in the traditional cyanidation. It also needs less dissolved oxygen, since Glycat reactions themselves act as oxidants. This minimizes oxygen consumption and reduces the risk of hydrogen cyanide release if pH level drop. The gangue dissolution is significantly less with Glycat due to its selectivity nature. This minimized dissolution indicates a more efficient process from a metallurgical recovery standpoint. Finally, when we look at the Watt cyanide, glycat show levels below 20 milligrams per liter. This is a substantial reduction from the typical range of 20 to 100 milligrams per liter found in the conventional cyanidation, indicating that glycat is a more efficient, safer, and less toxic technology. Well, let's see now some interesting possibilities of glycat. In this slide, these two graphs compare the traditional cyanidation versus glycat in a typical ore body. The main insights that can be captured here are, at first, glycat represents a significant advance in sustainable gold extraction, with an increase of 5.4% for gold recovery and 39% for silver recovery, respectively. Second, the sodium cyanide consumption was reduced by over 75% compared to cyanidation when using glycat. To conclude, the glycat case study confirms its technical viability and emphasizes its role in reducing the environmental impact of gold mining and the operational cost, and additionally increasing the metallurgical performance. Let's continue with another practical application. This slide highlights a transformative case study with glycat in the context of copper flotation tailings with tellurides. Our technology enables the global mining industry to unlock and monetize valuable metals in mine waste and tailings, reduce environmental liabilities, and improve economic, social, and environmental outcomes. The technical case here shows a significant increase in gold recovery. Due to the presence of residual copper, conventional cyanidation can be less cost-effective in flotation tailings. However, glycat improves gold recovery rates and significantly reduce cyanide use. Let's see two scenarios with different gold grades. The first one, the left side, in a sample with a gold grade of 0.24 grams per ton, glycat increased gold recovery to 62% from 35% while using less cyanide. The second one, the right side, in a sample with a gold grade of 0.2 grams per ton, a reduced glycat formulation also achieved a 62% recovery. Glycat resulted in over 60% gold recovery in both cases, highlighting its efficiency even with lower reagent levels. That's all I have for you today. Now I will hand it over to our GLT Global Leader, Santiago Garcia, who will discuss other practical technical cases in more detail. Thank you.
Thank you, Rodrigo, and hello, everybody. So we're going to continue talking about more individual cases. So in this particular case, we can see a comparison of glycat results with a regular cyanidation process for a gold and copper flotation concentrate sample. The test samples grades we can see in the slide are 35.9 grams per ton of gold and 0.36% for copper. These tests were run under regular conditions, 40% solids, pH 11, and room temperature. The added sodium cyanide, as we can see there, is reduced from 15 kilograms per ton for just a cyanide test to 4 kilograms per ton of cyanide and 4 kilograms per ton of glycine. Cyanide reduction represents about 75% less with the glycat conditions. Also, because the glycine used in the test was reported as glycine added during the bench scale tests, it doesn't include any recycling, which is achievable during operational conditions. Also, the gold recovery was slightly improved with the glycat conditions, which is another benefit observed in many cases when using our technology. As mentioned before, one of the most significant benefits of glycat technology is the downstream reduction of cyanide compounds formation. Because starting cyanide conditions are typical in the glycat environment, the amount of Watt and free cyanides are significantly reduced before detoxification. In this case, the operation was in an area that was sensitive to strict and environmental requirement conditions. The reduction of cyanide species before detoxification was drastically reduced and practically eliminate the necessity of using any detoxification reagents. Also, we can see the other cyanide compounds being reduced significantly, but we are not showing that in this specific graph. And this is a more detailed explanation about the costs, the impact on the operational costs. As we can see here, the overall reagent OPEX could be reduced because less cyanide is consumed in the process. And this slide is providing a real case example. The annual leaching OPEX costs, which is the first column on the left, is reduced from $48 million to $33 million, last column on the right, representing an overall 30% reduction in the total OPEX costs. The cyanide costs in the leaching OPEX represents around 41% of the total cost. Cyanide savings are around 14 million, as you can see in the second column, when using glycat. So the cyanide expense are reduced by 75%. Because glycat is used, so glycine has to be added, but there are also other cost benefits in the detoxification process, saving another $6 million. Overall, this mine will save around $15 million every year after implementing glycat. And this calculation doesn't include any potential benefit because of the gold recovery, which has been seen in many cases. Now I will turn over my colleague, Dan Child, GLT Global Commercial Leader.
Thank you, Santiago. We are working with many mines all over the world, with several projects in advanced stages in commercial production. Today, we're going to highlight just a few glycat commercial applications. First is Barrick Bulyanhulu in Tanzania. Many of you may have seen the recent press release announcing our strategic partnership with Barrick, as published in several mining journals last month. Bulyanhulu is a CIL operation and is the first Barrick site to achieve commercial use of glycat. Glycat reduced their cyanide usage by 80% while maintaining equivalent recoveries. Additionally, WAD cyanide concentrations now run below the regulatory limit prior to detoxification. Bayanereg in Mongolia was our first heap leach application. This case study was published last August on mining.com. Here, glycat reduced their cyanide consumption by 65%. More notably, their production was constrained by cyanide import restrictions, and the site was able to eliminate the risk of production stoppage due to cyanide supply interruptions. Next is the reprocessing of gold and copper tailings in Zimbabwe. The operation recovered both gold and copper from legacy tailings using the vat leaching process pictured here. The vat with the orange color in the foreground is where copper was precipitated. Glycat significantly reduced the cyanide requirements to extract gold, and this project ran for 18 months until all tailings material was exhausted. We currently have 10 pilots operating globally. We look forward to sharing more news of commercial scale implementations over time. We make regular announcements on our LinkedIn company page, so make sure to follow us there for the latest updates. We typically follow a 5-step engagement process to take glycat from the bench to full-scale production. First is discovery testing to ensure viability given an operation-specific mineralogy and recovery process. Over 90% of the samples we test reflect amenability to the technology. From there, optimization tests are conducted to dial in on the best parameters, and then we can estimate the benefit that an operation can expect to achieve with full-scale implementation. The third step is a pilot demonstration, and this can be conducted either on-site or at our technical center in Perth, Australia. Next, we issue a commercial license and conduct a trial in the operations process. This also allows us to optimize for performance. Once implemented full-time, we continue to provide technical support to ensure maximum operational benefit. From start to finish, this process generally takes 12 to 18 months and can be modified or accelerated to fit the needs of the operation. Our license model is comprised of 2 components. The license fee is based on the size of the operation, the value generated by the technology, then determined on a per ton basis with the operation capturing the majority of the benefit. This can be set up to be paid on a recurring basis or as a one-time upfront charge. A licensed subscription provides the benefit of ongoing technical support to ensure optimal performance and results. There are a number of standard plans available, or a custom plan can be generated to meet more comprehensive support requirements. The base level includes regular training, new technology rollouts, and annual audits to ensure best practices are maintained. We appreciate your time today. Jackson has been monitoring your questions and will now facilitate the Q&A session. Thank you.
Thanks, Dan. And to our other presenters, I'd ask if you turn your cameras on so we can all participate in the Q&A. So the first question came through on the side here. It says, how does cyanide leach native silver? I'm assuming that's how does glycine leach native silver? So Santiago, can you take that one for us?
Sure. For sure. For silver leaching, we have done tests mostly with the silver sulfides, mostly acanthite. So we can see very good results, especially if you can keep high the cyanide concentration in solution. The cyanide concentration is still low following the glycat principle. But for any kind of native silver, I think we'll have to do a particular test for that to see how the results are performing.
Thanks, Santiago. Next question says, the mining industry is under increasing pressure not to use high quality water. Some gold mines in Australia use hypersaline waters with high magnesium content. It's difficult and expensive to keep pH high due to magnesium oxide precipitation, leading to high cyanide consumption. How might glycine leaching help? And do you have any test work in these type of situations? Well, I can comment on this, and then Santiago or Rodrigo, feel free to chime in. We have actually done a fair amount of test work in Australia with hypersaline waters, and there's definitely some benefits there to using glycat. Santiago, I don't know if you want to add to that.
Yeah, so we have seen also good results using glycat even under those conditions. I think the main part is going to be handling really well the magnesium, but other than that, I think we can overcome any of those issues with our technology.
And again, so as we mentioned in the presentation, so glycat can actually operate at a wider pH range than cyanidation can because of the lower cyanide concentrations. So I guess the stress on maintaining pH will be reduced. And we're working on some other ways to, I would say, significantly reduce the amount of lime that's required for pH modification in those cases as well. So I'd love to talk more with you about that. Next question is, how is glycine delivered? So there's a couple of different package types I'm referring to. I'm assuming this is referring to the physical delivery. Pretty similar to sodium cyanide. You can get it in a super sack, which will then just be loaded into a mixed tank, the way that sodium cyanide boxes are. They can also be delivered in bulk as well. The next question, I'll tab for Santiago. Has this been trialed on a Merrill-Crowe process?
Yes. So we've been trying this technology under most of the typical recovery process, Merrill-Crowe and carbon, and we haven't seen any particular impact. But when we do the different testing for the different ores, we will recommend to do a particular test, what we call in stage 2, so we can particularly see if there is any impact for that specific ore.
Thanks, Santiago. The next one is asking about the chemistry that's taking place and how do we know that a majority of these results aren't just the result of leaning out the cyanide? So Santiago, I can help answer that, and I'll ask you to I guess, finish the response. So some of the benefit is the ability to reduce the cyanide concentration. When we compare glycat side by side with just straight cyanide in lab tests, we're able to achieve equivalent recoveries with glycat at lower cyanide concentrations than at an optimal, call it an optimal cyanide level. So if you're typically operating at we'll say 0.5 kilos per ton cyanide and achieving maximum recovery at that level. GlyCat will often be able to achieve the same level of recovery at 0.2 or 0.25 kilos per ton of cyanide, plus the added glycine. Santiago, I'll let you to add some comments there on the chemistry.
That's correct, Jackson. So when we do the test, we always have a baseline just with cyanide. And then on top of that, we try to demonstrate the GlyCat technology under different glycine and cyanide conditions. Really, GlyCat is very particular because can work in stark conditions for cyanide. That's, I would say, the most beneficial improvement on our technology. And the reason why is because the glycine is binding with all the other chemical consumers. It could be copper, zinc, whatever. And then the cyanide is mostly used for the precious metals, in this case, for example.
Thanks, Santiago. Dan, I'll give you the next one. Has there been a trial and a Canadian gold operation?
Sorry, helps if I'm not on mute. We have a number of projects in Canada, just as we do throughout the world, at a varying number or level of different stages. Currently, we don't have a current commercial application in Canada.
We do have some test programs and pilots that are progressing there, as Dan mentioned.
Correct, yeah.
The next one is there an intensive GlyCat or glycine leach to rapidly leach a high-grade gold or silver?
Yeah, I will cover that. So basically, again, when we're doing the test, the kinetic is always evaluated. And normally what we've seen is faster kinetic. But again, this depends on the mineralogy and the test that we have to perform on site. So I will say, by the way, our technology is going to be showing a faster kinetic compared to cyanide.
Thanks, Santiago. Next one, how is glycine recycled? The topic that is near and dear to all of our hearts.
Okay, so glycine is recycled back in the process solution, and basically, as you recycle back your solution after the CIL circuit, so and after the recovery process, the glycine also is going to be recycled back and can be reused. So let's say that the gold is attached to the glycine. So after going to the carbon column recovery process, so the free glycine is going to be liberated again and can be recycled back and can continue doing his work at the top of the CIL circuit. So that's basically how is the glycine recycle performing. So it doesn't need any chemical activation similar to sodium cyanide. So as soon as it's liberated as free glycine, it can be reused back in the process.
The next one is, so we noted that GlyCat selectively leaches certain elements, including copper. Does copper dissolution typically increase, which could create challenges with carbon loading as well as quality issues in the doré?
Yeah, that could be a potential case. That's why we have to do tests. There are some cases where we can see, well, in my experience, I have seen for GlyCat less recovery, less copper recovery, mainly because you are using less copper, less cyanide concentration in solution, right? If you have less cyanide, you are going to leach less copper, but we have to do tests to evaluate the downstream impact and the downstream effect.
And Santiago, in some cases, there may be, I guess, adjustments to the carbon absorption as well, right? Just to optimize the recovery of gold or optimize the recovery of the target metals.
Yes, so in case there is any copper loading, so you can handle this with a cold elution. That could be another option. And if you have too much copper in solution, you can also implement a copper recovery process in between, so you can handle the copper in your process. So we have a bunch of different options that we can recommend to our customers. But again, this has to be tested properly on site or during the discovery or stage 2 risk reduction process is what we call for our testing program.
Thanks, Santiago. So another one about the delivery of glycine. The question is, will it be dissolved in water, similar to sodium cyanide on site? Yes, that's how it works. Very, very similar. You'll just have a storage or distribution tank and a pump that'll pump it straight into the reagents area or the first leach tank. The next one is how to get a test of the GlyCat product. So this is a common misconception. So GlyCat itself is not a physical product. So it's our technology that's using sodium cyanide alongside glycine. So it's a patented leaching technique that uses both of those reagents. So as a sodium cyanide supplier, we can supply the cyanide. We also supply glycine as well. You can get both of the reagents from us. And then the engagement process that Dan laid out earlier is how we walk through testing GlyCat for your ore and then optimizing the reagent ratios, optimizing leaching parameters so that we can then scale up into a commercial environment. But the GlyCat itself is the technology, the chemistry approach that uses the two physical products, which are sodium cyanide and glycine. The next question is, are there any countries restricting your technology at all, like Kazakhstan, et cetera? So we actually have a technology leader on the ground in Kazakhstan, and we have some active projects there as well. So we're certainly able to implement in Kazakhstan. As to others, we have pretty broad patent coverage around the world, and the only places that are restricted for us as a company that has parent ownership in the Czech Republic and large operating entities in the US, or any that have current trade restrictions imposed by the US or the EU. Outside of that, we're able to implement it anywhere else in the world. Next one, Rodrigo, I'll give this one to you. Is the product environmentally friendly?
Yeah, well, glycine is an amino acid, so it's a friendly product and sustainable. So that's the main, advantage from an ESG standpoint.
Yeah, and I'd add to that too. Another significant benefit is the ability to generate much, much lower WAD cyanide from the process. When you talk to environmental regulators, like our EPA in the US, as an example, what they'll tell you is that their biggest issue with the use of cyanide is the impact that it has on the environment after the process takes place. So that's really focusing on discharge or effluent from the process. So the ability to generate a cleaner tailing stream, a cleaner effluent is really a major environmental benefit.
And if I may, a better answer, you're running the operation with less content of cyanide. So it means that in the WAD and in the product's different streams, you will have less cyanide. So that's another advantage.
Yeah, for sure. Next one for Santiago. Is gold recovery using this technology sensitive to changes in process temperature? Would operations in colder climates be challenged to maintain target recoveries?
Yeah, so the thermostability of the glycine or GlyCat is very robust, is very strong. So we can operate up to 100 degrees Celsius without no problem. And one of our operations in Mongolia actually is a commercial application, is using the GlyCat technology under freezing conditions, right? So I think they are way below 20 degrees and glycine is performing really well. So this is one of the beauties of the glycine, is very stable under a wide range of temperature that is giving us confidence that it's working properly in those conditions.
Thanks, Santiago. Next one, is the GlyCat technology applicable to double refractory gold ores that are not amenable to cyanide leaching?
Okay, so glycine is like the cyanide, right? So the ore has to be exposed in order to be leached. So this is as a general rule. So if the ore is refractory for any reason, could be locked in silica or could be associated to carbonaceous ore, it's not going to work. So the gold has to be exposed first, and then the glycine is going to do his work, leaching and reducing the cyanide consumption. We have seen some good benefit, especially for tellurides. As we expressed before, we did around a bunch of tests with tellurides presence in the ore, where we can see a significant improvement in the gold recovery. So we believe that the glycine is kind of breaking down the structure of the telluride, so that is improving the gold recovery. But this is still under research and understanding. We know the mineralogists are not the same around the world. So this is something that we still have to test and prove in the following years.
And we'll stay with a similar theme for the next one. Are there any mineralogies that are problematic? So obviously, in addition to the double refractory ores, any other mineralogies that you want to call out as being problematic? Santiago or Rodrigo?
Yeah, I don't think mineralogy is going to be any kind of, I will say, constraint for our technology. This is mostly related with the elements presence in the ore. So if the ore is able to be leached and could be leached by cyanide, so Glycat also can do his work. Other than gold locked in silica or any kind of refractoriness, if the gold is exposed and be able to leach, our technology is going to be able to do his work.
Dan, next one's for you. I'm going to generalize this one slightly. So the question we'll pose is, what is the duration of a typical pilot program or pilot operation? Oh, you're on mute, Dan.
Yeah. I'm going to say it depends. These can go anywhere from, say, 30 to 90 days. Depends on the variability of the ore or the scope, how the pilot is scoped out. But I think in general, 30 to 90 days, largely as a result of the site requirements.
Okay, next question is, are there any potential interactions with the free glycine in recycled processed water and any other reagents? And I guess I'll amend that because we get this question often. Will glycine impact the flotation process? Santiago.
Yeah, so what we found out so far is that glycine could help with the sulfides activation. So I think we still have to do more work on this field. And we always recommend to our customers also to include during our discovery test stage to test what will be the impact of the glycine presence in the flotation circuit. But what we have seen so far is that it's helping activating some sulfides. So other than, I will say, impacting negatively the flotation circuit, is going to improve the recovery.
And we'll stay with a similar vein here. How much glycine carries over into the carbon acid wash, elution, and electrowinning? And are there any negative impacts on these downstream processes?
Yeah, so we believe that probably some of the glycine could end up attached to the carbon. We don't think it's a significant amount because basically the glycine molecule is big enough to be completely absorbed in the carbon process. But in case you have some, it will be managed properly during the stripping process without any problem. So it's not going to be attached after stripping or regeneration. So the regenerated carbon is going to be fully available after the regeneration process.
So the next question is, some provinces in Argentina totally prohibit the use of cyanide. Do you have a way to not use it? That's a great question. We do have a few different approaches to this. And I invite you, Claudio, on our final slide here, I think we should have a a link that you can use to get in touch with us. We can discuss that more in detail with the specific application that you have in mind. Next question. Again, I'm going to generalize this one. How do we monitor the concentration of cyanide during our pilot programs?
Yeah, it's very similar. We normally use the silver nitrate titrations. Is very typical for the pre-glycine determination. So you can use the same procedure as we are using in a regular cyanidation process. So it's titration with silver nitrate.
Thanks, Santiago. I've got a few more frequently asked ones here. So can GlyCat leach gold from copper tailings?
Absolutely. I think that's one of the main benefits of our technology. It can do in a very reliable way, reducing the amount of cyanide consumption. As we know, copper likes cyanide a lot, and that's the reason why the mines are using a lot of cyanide. So our technology can do this without any problem, maximizing or having the same or even better gold recovery with a lower cyanide consumption in the process.
Thanks, Santiago. Next question is about an affiliate metallurgical labs in Canada to support a pilot test program. So we do work with SGS Lakefield at some scale of testing. We also would support this out of our lab in Perth, Australia as well. So I invite you to get in touch with that. We can discuss a test program. Do we also offer this technology for tungsten, silver, or rare earth metals at all? Santiago, I'll let you take the tungsten silver question. I think that's a specific mineralogy, and I'll handle the rare earths.
So I think tungsten is an interesting particular case. We'll have to do the tests. If this is part of the PGN group, or if this is part of the selected group that we know that the glycine can leach, I think we have a very confident that could work, but we will need to do the test for sure to understand better what would be the performance.
And then on the rare earth metal side, we've not done any work in this area yet, so cannot comment on that. Okay, just a few more frequently asked ones. Rodrigo, is there a minimum ore grade that GlyCat needs to work?
Well, it depends. That's a tricky question. But I think that the invitation is to review the ore with our team as well, and to provide you visibility about the potential of the real opportunity. So we've got more than 3,500 hours of piloting, a proven track record running different tests. So we are in a good position of advise different mining companies about different ore types and opportunities.
Yeah, but probably to add a little bit there. So as we know, our technology is reducing the operational cost for sure. It will improve the viability of the project, right? So it's going to reduce the operational cost. So it's going to open the opportunities to expand the pit size or do better with the economics. But so if it's not economical with cyanide, I think it would be interesting to see if it's economical or not with our technology. But it all depend on the economics, right? I think the gold grade is relative to the pit size, the operational costs, etc. So economics will have to be involved to take the decision.
And I'll add that we have seen quite a few cases where GlyCat was able to improve operating costs of certain deposits or projects, and definitely improve the financial viability of them. Okay, well, it looks like we've come to the end of the questions. I appreciate everybody in the audience taking the time to join us today, and appreciate all of the questions and discussion. I'd invite you to please go to the link on the screen here, dresslovka.com/GLT. We'd love to talk more with each of you individually about the specific projects or specific applications that you have in mind, and look forward to talking to everybody on the call here. So thanks again for joining us.
Thank you, everybody. Have a great day.
Thank you.
Thank you.
Bye-bye.
Have a great day.